Hello, everybody. It is May 22nd, 2024, and I'm delighted to be able to have Batmanosama with us today here in the Agora Forum Auditorium, uh, teaching us about DSPy, which is programming with foundation models. Batman is a solution architect at Nemastex Labs, and I'm looking forward to hearing his perspectives on DSPy and having him teach us how to use them. Thank you so much. If anybody has a question, please raise your hand or interrupt. I'll be watching the chat.
Alrighty. So, yes. Excellent. So, yes, I want to introduce everybody to DSPy. Uh, it was introduced a couple years ago as essentially as DSP, which stands for Demonstrate, Search, and Predict. They have recently incorporated a few different new features, which they have more so incorporated the Python language and the framework. Um, and so, with that, I will begin by demonstrating a few of the uh, notebooks that they have, um, and I will go through them with the audience. So let's begin. Um, Also, let me get the chat up as well. All right. Actually, let's do it more like this. Hold on.
Take your time. It everything
All right.
flows with the wrong font.
I just want to make sure that everybody can still see. There we go. That's a little
Thank,
bit better. And
thank you.
then, all right. So that still looks good. Okay. So, so to set up, okay. So to start off, DSPy emphasizes programming over prompting. So, pretty much what DSPy does is it standardizes prompting and evaluation for composing language model application or programs. And so by doing this, it unifies techniques for prompting and fine tuning language models, as well as improving them with reasoning and tool retrieval augmentation, all expressed through a minimal set of Pythonic operations that compose and learn. So basically, typically, you would have, I would say, 10 to 20 lines of code in order to instantiate and use language models for tool and retrieval augmentation. With DSPy, they use a minimalistic set of Python operations in order to standardize and minimalize the code need required in order to quickly instantiate these language models in order to compose novel um, applications. So what DSPy provides is composable and declarative modules for instructing LMs in a familiar Pythonic syntax. On top of that, DSPy introduces an automatic compiler that teaches LMs how to conduct the declarative steps in your program. Uh, the DSPy compiler would internally trace your program and then craft high quality prompts for large language models or train automatic fine tunes for small language models to teach them the steps of your task. Okay, so what that means is DSPy has the ability to not only get your language model up and running quickly. You can also basically configure uh, your language model through signatures and modules, and then compile and save those configurations and use them later for training or fine tuning downstream. Okay, so let's get started. So by setting up, um, we'll uh, we'll okay. We'll start to see below. DSPy can routinely train powerful models like GPT 3.5 and local models like T5 base or Llama 2 3B 13B to be much more reliable at complex tasks. So basically, it improves module or language models that uh, struggle in reasoning tasks uh, and other features, and it basically allows them to be trained or fine tuned to have uh, enhanced abilities. So DSPy will compile the same program into different few shot prompts and fine tunes for each language model. Okay, so we're gonna begin by setting everything up, and we're gonna instantiate our models. Or first, we're gonna install our dependencies. All right, so to get started, uh, so DSPy has language models and retrieval models. Okay, so we'll get started by setting up both. Um, DSPy supports multiple APIs and local models. In this notebook, we'll work with GPT 3.5 and the retriever model Colbert V2. To make it easy, we'll set up V2 server hosting, Wikipedia 2017 abstract search index. Uh, it's going to contain examples, or it's going to contain first paragraphs of each articles from that 2017 dump. So you don't have to worry about setting it up. It's free. It's already hosted. If you want to run this notebook without changing the examples, you don't need an API key. All examples are already cached internally, so you can inspect them. So let's run that. In the last line above, we'll configure DSPy to use Turbo LM and Colbert V2 Retriever over Wikipedia 2017 abstracts by default. This will be easy to overwrite for local parts of our program if needed. All right, so you can build your own DSPy programs for various tasks, question answering, information extraction, or text to SQL. Whatever the task, the general workflow is collect a bit of data, write your program, define some validation logic, compile, and then iterate. Okay. So let's go over each. So when you collect a little bit of data, you'll be defining examples of the inputs and outputs of your program. Questions, whether that be questions and answers, etc. This could be a handful of quick examples you just wrote down. If large data sets exist, the more the merrier. So you can create dummy data sets, or you can use already established larger data sets. Um, Now, writing your program, you have to define modules, which in your modules you'll have, what constitutes those modules, which will be the signatures that dictate the inputs and outputs, which will be, in this case, subtasks of your program, and the way they should interact with each other to solve your task, which will be the forward pass. So we'll get into that later. So define some validation logic. Okay, so what makes for a good program to run? So let's depending on your situation, you might be dealing with textual data, so you might want a readability metric. Um, you need to figure out what's good for your use case, and then you'll be able to incorporate that into your teleprompter. Uh, so maybe the answers you need, uh, maybe the answers need to have a certain length or stick to a particular project. Format. Specify the logic that checks that. That's going to be your metric, right? And then you're going to compile. Ask DSPy to compile your program using your data. The compiler will use the data and validation logic to optimize your program, e.g., the prompts in your modules. So it's efficient and effective. And then you iterate. Repeat the process by improving your data, program validation, or by using more advanced features of the DSPy compiler. All right, so let's see it in action. So DSPy uses examples in order to incorporate data sets into its evaluation. So DSPy accommodates a wide variety of application and tasks. In this notebook, we will work through example tasks of multi-hop question and answering. So let's take a look. So they have a few data sets that they support within DSPy. One of them is Hot Pot QA. And so what we do is we're going to load a, tr- a test set, or excuse me, a dev set, and then we're going to tell DSPy the question field for the input. Any other fields or labels and or metadata. Okay, so we're setting that here. All right, so let's run that. All right, so we just loaded 20 train set examples and 50 dev set examples. Each example in our training set contains a question and its human annotated answer. DSPy typically requires minimal labeling, whereas your pipeline may involve 6 or 7 complex steps. You only need labels in order. You only need labels for the initial question and the final answer. DSPy will bootstrap any intermediate labels needed to support your pipeline. If you change your pipeline in any way, the data bootstrap will change accordingly. Now let's take a look at some data examples. So we're going to print some examples out to see what they look like. So it's already done, but we'll run it again. At question at my window. Okay, so it's just printing out the data set. Examples in the dev set contain a third field, namely titles of relevant Wikipedia articles. This is not essential, but for the namesake of this intro, it'll help us get a sense of how well our programs are doing. So let's go ahead and let's print. Question, what is the nationality? English. Okay. Relevant titles. After loading the raw data, we applied X with inputs question to each example. So this is how you load in raw data with DSPy. It has to be with inputs. To tell DSPy that our input fields in each example will be just a question. Okay. Any other fields are labels or metadata that are not given to the system. Okay. Now that there's
Sorry to
nothing.
interrupt here. Um,
Okay.
Am I reading it correctly that the first item there, the for this data set, training examples will have input keys and label keys? That's how you let DSPy, DSPy know about the signatures? Is that how you tell it, the signatures?
So right here, this is how you tell it about this specific key in this data set. So you're labeling it. So you're giving it explicit knowledge of this data set, and you're labeling it as a question.
Okay.
And anything else. So if you so you have to specifically do it for the ones that you want to incorporate in your composition.
Thank you.
All right, no problem. So so there's nothing special about the Hotpot QA data set. It's just a bunch of examples. You can define your own examples as below, so you can have custom examples. So a future notebook. Okay, so yeah, they'll show you about how if you don't have that much data, or if you want to create synthetic data, etc. All right, so building blocks. In DSPy, we will maintain a separation between defining your modules in a declarative way and calling them in a pipeline to solve a task. Okay, so this allows you to focus on the information flow of your pipeline. DSPy will then take your program and automatically optimize how to prompt or fine tune LMs for your particular pipeline so it works well. If you have experience with PyTorch, you can think of DSPy as the PyTorch of the foundation model space. Before we see this in action, let's first understand some key pieces. Using the language model, okay? So using the language model, we have signatures and predictors, right? Every call to the LM in DSPy program needs to have a signature. A signature consists of three simple elements: a minimal description of subtasks the LM is supposed to solve, a description of one or more of the inputs that we will give to the language model, or a description of one or more outputs, the questions answered that we will expect from the LM. Let's define a simple signature for basic question answering. So as you see here, this is a class-based signature where we have some doc strings that are describing this what the what it's supposed to do, and then we also have the question and answer outlined specifically as input fields and output fields. 1 second, please.
Take your time. So it appears that the signature is fairly critical for getting right. If you don't get the signature right, then DSPy doesn't know what the input is, doesn't know what the output is, and doesn't have an idea what the task is.
Exactly. So you have to explicitly, set, and that's the beauty of, DSPy, is that you're able to, with natural language, and even with notation, or shorthand, dictate, your inputs and your outputs. So in the basic QA, the doc string describes the subtask where the question answers or answering questions is happening. So answer questions with a short factoid answers. Okay. Each input field or output field can optionally contain a description too. See that at the bottom is we have the output field, but we also have a description further, refining how we want the output to be. So it's often between 1 and 5 words, right? So when it's not given, it's inferred from the field's name, e.g. question. So even if you don't have it, it's still okay. All right. Notice that there isn't anything special about the signature in DSPy. We can just easily define a signature that takes a long snippet from a PDF and outputs structured information for an instance. Anyway, now that we have a signature, let's define and use a predictor. So he was just saying the PDF as an example. Uh, but yeah, so now that we have a signature, let's define and use a predictor. A predictor is a module that knows how to use the LM to implement a signature. So with these modules, okay, so we have these different type of modules. We have predict modules. We also have chain of thought modules. So these modules are basically patterns, are basically prompting patterns that are incorporated into DSPy, and you're able to use them throughout the composition. So, or throughout your modules. Uh, okay. Now that we have a signature, we can define and use a predictor. A predictor is a module that knows how to use the LM to implement a signature. Importantly, predictors can learn to fit the behavior to the task. So, we're going to define the predictor, generate answer from the predict module, inherit the basic QA signature. Okay. We're going to call the predictor on a particular input, which is going to be from the def set question, right? And then we're going to print the input and the prediction, right? So it's going to run a prediction on that particular input, which was from that dev set, right? Based on the signature. Okay, so this is it in action. Well, hold on. Uh, let's see. Yeah, so it's not able to. Well, let me do this first.
There we
go. Okay, hold on. I thought I already instantiated.
Need to go all the way up. There we go. That ran. That ran. Okay.
Okay. Hold on.
That ran. That ran. That ran. That ran. That ran. That ran. Huh. I don't know why that didn't go.
Variables, secrets.
API key? It's not happy about the OpenAI key. I wonder if it's expecting you to be running it within Colab, where you could have an API key within the environment, but that's just a guess.
Yeah, that's what I'm probably gonna end up doing. Mainly because I'm not trying to show my key right now, but
yeah.
For now, let me just reload.
Thank you. Thank you. Take your time.
Okay, so because I don't necessarily need my key. I just need to show you the outputs, which it's already cached. So, all right. So, what is the nationality of the chef and the restaurant featured in the restaurant's Impossible? Okay, and it says it's impossible question mark predicted answer American. All right. So in the examples above, we have asked the predictor about the chef featured in the restaurant Impossible. The model output is answer American. For visibility, we can inspect how this extremely basic predictor implemented our signature. Let's inspect the history of LM Turbo. So in DSPy, it has a debugging feature which is dot inspect history. So with the language model, retrieval model that you're dealing with, you're able to attach this to it and then determine how many iterations you want to look at. So with this one, we're just going to look at one, or the most recent. And you see here it says that. So this is kind of showing you the under the hood of what the turbo LM predicted or as generated. So it's getting this answer the question with this short factoid. This is from the signature, and then it says follow this format, and then it's got the question, and answer, and then often between, and it's telling it often between 1 and 5 words, and then it's giving it the question from the data set, which is what is the nationality, and it's the possible, and then answer American. Okay? And that's the prediction that it's running. So it's giving this question and it's running it based upon this format. Okay, so it happens that this chef is both a British and American, but we have no way of knowing if the model just guessed American because it's a common answer. In general, adding retrieval and learning will help the LM be more factual, and we'll explore this in a minute. But before we do that, how about we just change the predictor? It would be nice to allow the model to elicit a chain of thought along with the prediction. So to do that, we will define the predictor. Okay, notice that we're just changing the class, The signature basic QA is still unchanged. So instead of doing predict, we're doing chain of thought now. All right, call the predictor in the same on the same input, so everything still says the same. Print out the chain of thought and the prediction. So now we're going to print out the predicted answer, which is also going to print out the chain of thought as well. So thought, predict, rationale, because you get a rationales with the chain of thought. All right. Question: what is the nationality? Okay, still possible. Thought. Now you get chain of thought. We know that the chef and restaurant featured in the restaurant is impossible in Robert Arvine. Predicted answer: British. This is indeed a better answer. The model figures out that the chef in question is Robert Arvine and correctly identifies that he's British. So this kind of gives the LM a more pronounced ability to reason and differentiate. Okay, so below, as we see below, they can be also be optimized to learn from your data and validation logic. So using a retrieval model. All right, so now we're going to go to retrieval models. So we just did a language model. We just went from predict, which is just doing basic predictions. And sometimes they can be spot on, but sometimes you might need more complex reasoning, which you will use a chain of thought. And they also have other patterns as well, other than just chain of thought. They have chain of thought with hint. They have react. They have all different types. So now we're going to go into retrieval models. So using a retrieval model using DSPy is pretty simple. A module a module DSPy.retrieve k will search for the top k passages that match a given query. By default, this will use the retriever we configured at the top of this notebook, namely Colbert v2 over a Wikipedia index. So what this is doing is this is pulling another module. We have another module called retrieve. So we had a module called predict, right? And now we have a retrieval module, okay, called retrieve, and it automatically pulls the top k from the given query. So this is how you instantiate. So, or you instantiated earlier. This is how you call it. So retrieve DSPy.retrieve, and you can dictate how many. We're doing the top 3. Then you do top k passages equals retrieve, and then we're going to pull from the dev set from the question from the passages, and then we're going to print the top k passages for question, and then we do some formatting. Um, so now we have top three passages for question. What is the nationality of the chef and entrepreneur featured in the restaurant? Impossible. Number one, restaurant, impossible. Restaurant Impossible is an American reality television series featuring chef and restaurant Robert Irvine that featured on Food Network. Okay, so you see now that it's showing you these three pulled, retrieved uh, uh, data sets. Okay, feel free to query. Feel free to any other queries you like. So now we're able to query when was the first FIFA World Cup held. So now we're just asking questions, okay, to the data set. Okay, history of the FIFA World Cup. FIFA, and then it's giving you an answer. Okay. All right. So now let's create a program. So program one, basic retrieval augmented generation. Let's define our first completed program for this task. We'll build a retrieval augmented pipeline for question answer or answer for answer generation. Given a question, we'll search the top three passages in Wikipedia, then feed them as context for answer generation. Let's start by defining a signature. So this is how you do signatures. Um, you have the doc string that describes what the signature will do, and then you can have descriptions in the actual for each variable in the signature. So the context, we're going to describe it a little bit more. We're going to say it's going to may contain relevant facts. Question is just going to be an input field, and then we're going to allow the language model to decide to infer. And then the answer, we're also going to give it some more help, saying often between 1 and 5 words. All right. So now let's define the actual program. So all or the classes, they inherit from a DSPy module. Okay. So in a module, it needs two methods. The init methods will simply declare submodules. It needs a retrieve and a chain of thought. So for our RAG module that we're going to create, we need two submodules. We need retrieve and we need the chain of thought. So the latter is defined to implement our generate answer signature. So what we're going to do is we're going to implement these in the for pass. So the for method will describe the control flow of the question answered that we have. So in it, we're going to use the retrieve module to inherit the question and then run that through the passages. Okay, and then we're going to do prediction, which is going to do this generate answer with the context and the question. All right, and then we're going to return a prediction based off the context and the action that has the predicted answer. Okay, so the beauty of this is that we're able to compile the RAG program as well. So now that we define the program, we're able to compile it. Compiling a program will update the parameters stored in each module. In our setting, this is primarily in the form of collecting and selecting good demonstrations for inclusions in your prompts. Compiling depends on three things: a training set, metrics for validation, and specific teleprompters. So let's talk about the first thing, which is a training set. Uh, Earlier, you saw we used 20 question answer examples from the train set that we defined, and then the metric we saw that we defined a quick validate context and answer that checks the predicted answer. If the predicted answer is correct, it also will check the retrieved context. It'll also check that the retrieved context that does not actually contain the answer. So it'll make sure the efficiency of checking the answer based on the context is there. All right, and then uh, you need to have a specific teleprompter because DSPy has many different teleprompters. Uh, so the DSPy compiler includes a number of teleprompters that can optimize your prompt. So now let's talk about teleprompters. All right. The most basic one is Bootstrap Few Shot, but let's kind of go over some of the other ones like random search. Uh, Teleprompters are powerful optimizers that can take any program and learn to bootstrap and select effective prompts for for their modules. Okay, so they're able to optimize whether your signature for your modules or just the signatures themselves. So different teleprompters offer various trade-offs in terms of how they optimize cost versus quality, etc. The most simplest use is, or excuse me, we'll just use a simple default bootstrap few shot in this notebook. So if you're in analogies, you could think of this as your training data, your loss function, and your optimizer in the standard DNN supervised learning setup, whereas the SGD is a basic optimizer. There are more sophisticated and more expensive ones like Atom and RMSP prompt. All right, so we're going to show how just using the basic bootstrap few shot is able to use this validation logic. So the validation logic checks that the predicted answer is correct. It also checks that the retrieved context does not actually contain the answer. So there's two. There's two things that it's going to check for. That's going to run through the evaluator. Uh, the first one is the answer is it the exact match, okay? And then the second one is it does it actually contain the actual answer in the passage. All right. So we set up a teleprompter that's going to take that validator and then run it through the bootstrap few shot. And then afterwards, we're going to compile it. All right. So this one compiled after 10 iterations. Bootstrap 4 full shot traces after after 11 examples. Okay. Now that we've compiled our RAG program, let's try it out. Okay. Ask any question you like to this simple RAG program. My question: what castle did David Gregory inherit? It's going to get the prediction that contains context and answer, and then it's going to print the context and the answer. Question: what castle did David Gregory inherit? Kennedy Castle. Retrieve context, truncated. It's giving you the excerpt, right? Now let's inspect the last prompt from the LM to see exactly what it did, where it got its answer from. So, answer short questions with short factoid answers. Answer or question. Um, At My Window was released by which American songwriter? Answer: John Tom Van Zant. Okay, so it's going through these questions, it's answering them, and these are basically improving its understanding on how to run through this RAG program. And by the end of it, it's optimized at using this data set in this way to the point where it can one shot the question and answer, and it gets Kennedy Castle off of the original question, which is what castle did David Gregory inherit, right? So even though we haven't written any of the detailed demonstrations, we see that DSPy was able to bootstrap this 3,000 token prompt for 3-shot retrieval augmented generation with hard negative passages and chain of thought through our extremely simple program. Okay, so this illustrates the power of composition and learning. Of course, this was just generated by a particular teleprompter, which may or may not be perfect in each setting. As you'll see in DSPy, there is a large but systematic space of options, so you can optimize and validate the quality and cost of your programs. So if you're so inclined, you can easily inspect the learned objects themselves. So in here, we're going to show uh, some of the learned examples. So this is a generated answer. Um, Context Taekwondo times. So like it gives you kind of context. It gives you the thought process. Okay, so let's evaluating the answers. Now that we can evaluate our compiled RAG program on the dev set, of course, this is a tiny set that is not meant to be a reliable benchmark, but it'll be instructive to use for our illustration. For a start, let's evaluate the accuracy, exact match of the predicted answer. So we're going to run this through the evaluator. We're going to do exact match for the answer. And we see that through running it through 22 uh, attempts, we got 44%. Okay, which is not too bad, but we can do better. So we have the question, example answer. If the example is answered yes or no, um, and then the goal titles with the context, and then answer exact match if yes, if for true or false, right? And then we go through all of these 45 rows, and we only got 44%. So evaluating the retrieval, it may be instructive to look at the accuracy of retrieval. There are multiple ways to do this. Often we can just check whether the retrieved passages contain the answer. That said, since our dev set includes gold titles that should be retrieved, we can just use these here. So now we're gonna look at the gold retrieved, and we're gonna go ahead and map them out, and then normalize the text so we can look at them, and then return the found titles. Okay. So although this simple compiled RAG program is able to answer a decent fraction of the correct questions correctly on this tiny set, over 40%, the quality of the retrieval is much lower. This potentially suggests that the LM is often relying on the knowledge it's memorizing during training to answer questions. To address this weak retrieval, let's explore a second program that involves more advanced search behavior. All right. So this is kind of the beauty of DSPy is the ability to do multi-hop, which is an iterative search, which is adding to the context of the LM in order to create more refined structured outputs. So from exploring the harder questions in the training dev sets, it becomes clear that a single search query is not enough for this task. For instance, this can be seen when a question asks about say the birth city of the writer, right back at it again. A search query identifies the author correctly as Jeremy McKinnon, but it wouldn't figure out where he was born. The standard approach for this challenge in the retrieval augmented natural language processing literature is to build out multi-hop search systems like GoldN and Baleen. These systems read the retrieved results and then generate additional queries to gather additional information if necessary. Using DSPy, we can easily stimulate these systems in just a few lines of code. We'll use the generate answer signature from the RAG implementation above. All we need now is a signature for the hop behavior, taking some partial context into question, generate a search query to find missing information. So what we're going to do is, like they said, we're just going to take the generate answer sig from above, and we're going to you know enhance it with the hop behavior, which is basically um, giving it some partial context in a question. So we give it some doc strings with a description. Write a simple search query that will help answer a complex question. Then we set it up with the context as the input, and we just give it a simple description, question, and then the query is going to be the output. Now we could have written context equals generate answer signature dot context to avoid duplicating the description in of the context field, because you're able to write signatures out like that as well. Uh, uh, but we wrote it out as a class. So now let's define the program itself. Simplified Baleen. This is the multi-hop. So there are many possible ways to implement this, but we'll keep this version down to the key elements for simplicity. So this is the most simplicated version of multi-hop that they have so far. All right. So they instantiate the different passages per hops that they're going to take, and then max hops for each, which is going to be 2. So they're going to generate query. They're going to do chain of thought with the query, and they're going to pull in the signature, and it's going to be within the max hops, right? And then so they're going to instantiate the program, instantiate the retrieve module, instantiate their answer module with the correct signatures, and then they're going to run their forward pass, which is going to make context empty, because they're going to iterate over it and be adding to the context. And then for each hop, they're going to or it's going to be within the range, and then they're going to run the query, and then they're going to make sure to for each hop add to the query based on the context and the question, and then retrieve each passages um, uh, with the query as well, and then to take off any type of duplication of the context but the passages. And then they're going to run prediction over that, and then generate an answer, and then return that prediction. Okay, so as we see in the init method, it describes a few key submodules. First, we have the generate query. For each hop, we will have one DSPy chain of thought predictor with the generate search query signature. All right, and then with the retrieve, this module will do the actual search using the generated queries, and then we're going to use it all together and generate answer, which will use the predict module after all the search steps, and then it will use the generate answer to actually produce an answer. Okay, so the forward passes uses the submodules in a simple control flow. First, we loop, based upon the max loops times, and then each iteration will generate a search query, using the predictor at generate query per hop. Okay, and then we'll retrieve the top k passages using that query, and then we'll add to the deduplicated passages. Okay, make sure we don't have any duplications to our accumulator context. After each loop, we will use the self-generate answer to produce an answer. We will then return a prediction with the retrieved context and a predicted answer. That's when we combine it. All right. Inspect the zero-shot version of the Baleen program. We will also compile this program shortly, but before that, we can try it out in a zero-shot setting, i.e., without compilation. Using a program in zero-shot, uncompiled setting doesn't mean that the quality will be bad. It just means that we're bottlenecked directly by the reliability of the underlying LM to understand our subtasks from minimal instruction. Okay, so that just means that, like you just said, it won't have those examples. So this is often just fine. This is often just fine when using the most expensive, powerful models like GPT-4 on the easiest and most standard tasks. e.g., answering simple questions about popular entities. However, a zero-shot approach quickly falls short for more specialized tasks, for novel domain settings and or for efficient and or open models. So depending on the complexity and if you're using open models, using uncompiled DSPy programs is going to have lower results. But DSPy can help you in all these settings. Okay, so we can ask questions um, you like in a simplified RAG program. So we just have our question. Then we get a prediction that is contains the context and answer in an uncompiled Boolean. So we're just gonna satiate our module, and then we're gonna run prediction over it based with our question, and then we're just gonna print, the question and the answer with the context. So we have our question, which is how many stories are in the castle that David Gregory inherited. Answer 5. Retrieve context. This is where it's getting. This is what is basing this answer on because it's combining that with the question. So it has all of this in the context, and in here it has somewhere that is 5 stories. uh, so let's inspect the last 3 calls for the LM, i.e., generating the first hop query, generating the second hop query, and generating the answer. So in here, let's see. Write a simple search query that will help answer a complex question. Um, we have here the signature, and then we have the outline of our module. So it has follow the complete format where we have the context, which we in our signature we're dictating what the inputs and outputs are. Which we described. It may contain relevant facts. And then we have the question, which we didn't, and we said that the LM was able to infer. And then we have the reasoning, which that comes with chain of thought. So let's think step by step in order to produce the query. And then we have the query. All right, and then context not available, question, reasoning. Okay, which is how many stories. Okay, reasoning. Let's think step by step in order to find the question. First, we need to find this information about Gregory. Okay, so that's where the chain of thought comes in, and it's giving you that step by step. And then 5, right? Okay, so now it's time to compile our multi-hop simplified program. First, we will first define our validation logic, which will simply require that the predicted answer matches the gold answer. The retrieved context contains the gold answer. None of the generated queries is rambling, i.e., none exceeds 100 characters in length, and none of the generated queries is roughly repeated, i.e., none is within 0.8 or higher F1 score early the query. So these are some of the metrics that we're dictating. Okay, so in our compile, we are setting validate context and answer in hops. We're saying if not, exact match or passage match, run it through the hops. Okay, and then if max. Okay, so basically we're saying this is our validation logic to say if none of these things are happening to compile. So like we did for RAG, we'll use one of the most basic teleprompters, Bootstrap FewShot. Okay. Now let's evaluate the retrieval. Earlier, it appeared like our simple RAG program was not very effective at finding all evidence required for answering each question. Is this resolved by adding some extra steps in the forward function of the simplified Boolean? What about compiling? Does it help for that? So there was 2 options. You can add extra steps in the forward, or you could just simply compile your program to see if that increases your results. So the answer the answer for these questions is not always going to be obvious. However, DSPy makes it extremely easy to try to make diverse approaches with minimal effort. So let's evaluate the quality of retrieval of our compiled and uncompiled Bayesian pipelines. So with that, we have um, uh, both pipelines being ran, and we have uh, similar similar results, right? Um, or actually, no, we have gold passages retrieval. So yeah, we're printing out. We run an evaluation, and then some of it is truncated. Oh, okay. And then we're gonna print the retrieval score for the RAG, retrieval score for uncompiled Bayesian, and then we're gonna do the retrieval score for the compiled Bayesian. So it was showing you the compiled Bayesian, and then these are the actual scores for them. So as you see that the sometimes you don't have to necessarily add more steps in your forward pass. Sometimes all you have to do is simply just compile your program in order to get better results with your open or lesser models like GPT 3.5, because this 60% is comparable to standard RAG with uh, GPT-4. And then, okay, so excellent. There might be something that to this compiled multi-hop program then, but this is far from all you can do with DSPy. DSPy gives you a clean space of composable operators to deal with any shortcomings you see. We can inspect a few concrete examples. If we see failures causes, we can expand our pipelines by using additional submodules, maybe summarizer after retrieval. We can modify our pipelines by using more complex logic. Maybe we need to break out of the multi-hop loop if we found all of the information we need. Refine our validation logic. Maybe use a metric that uses a second DSPy program to do the answer evaluation instead of relying on strict string matching. This is something that I'm working with. And then also use a different teleprompter to optimize your pipelines more aggressively. For example, you have the DSPy or the bootstrap few shot, and you have the bootstrap few shot random search, which is for more unexplored space if you want to do a deep breath search, and you have more tokens to expend on the actual optimization, and others. There are others as well. And then use yeah, and then five, add more or better training examples. And this is something that I struggle with, is creating custom data sets and adding better training examples, because that definitely affects the outputs of your compiled and uncompiled programs. Or if you really want, we can tweak the descriptions and the signatures we use in your program to make them more precisely tuned, or excuse me, precisely suited for their subtasks. This is akin to prompt engineering and should be a final resort, given the powerful option that DSPy gives us. Even if all else fails, we're able to actually specifically set our signatures prompt formats as well. So right here, you're able to how many stories are in the or we're asking a question to the compile Bayesian, and we're gonna inspect the history to see how it takes this question. So we write a simple question or write a simple query that will help answer a complex question that's based on the signature, and then you see how the signature is set up in the actual forward pass of the module, which is follow this format, may contain these questions, et cetera, et cetera. And it gives you the answer 5. So yeah, this just shows you how you can ask the same question and then get even better results with only having to go through 3 examples. Yeah, so this is the intro to DSPy. I have a few other examples that I would like to also go over. Few of them are a little advanced, and then others are, I would say, in the middle. So yeah, I would also take questions at this time. If anybody had any questions or had any topics that they want to bring up as well.
I'll open the floor to questions as well. I'm a little puzzled about what they mean by a teleprompter. Is that just a
Oh,
PyTorch optimizer?
yes, that's exactly what it is. So, like they said, you can think of it as like Atom. So we can go to their docs. Deep dive teleprompter. All right, and let's look at the bootstrap. So this doesn't look that good. That's okay. So when compiling a close this. But okay, so when compiling a DSPy program, we invoke a teleprompter, which is an optimizer that takes a program. Um, so in here, we simply take, let's see, right here, we use the Bootstrap few shot teleprompter, which takes a metric, um, which is the GSMAK metric, and then it runs it through certain demonstrations. And then we also have label demonstrations. Um, and then, okay, so a metric is an obvious parameter, but there are max, but what are max bootstrap demos and max label parameters? Let's see the difference on the table. So let me, because I know this is going to probably be what we want.
So those both
Change
appear to
the
be a number of bootstrap demos and label demos, and not too many of them. 8 is a small number. Um,
Yes. So with the random search, I believe you would want a smaller number, and then okay. So depending on how many demonstrations or how many examples you have, they have specific teleprompters that are more optimized for larger and smaller data sets. So let me. I think my screen is showing. Is it this one?
we're looking at a YouTube window at the moment, and your
Okay.
stream
Good.
has
Good. Good.
paused.
Okay. So let's go here. All right, and then let's go, or not there, let's go. Here we go. Yeah. Okay, trying to see where I was just at. That's all right. So the max bootstrap demos is the number of additional examples generated by the teacher. So the bootstrap few shot Okay, so they have a few different parameters that they use. So it uses a teacher module, which is default to your program, to generate complete demonstrations for every stage of your program, along with the labeled examples in the train set. Parameters include max label demos, the number of demonstrations randomly selected from the train set, and max demonstration demos, the numbers of additional examples generated by the teacher. The bootstrapping process employs the metric to validate demonstrations, including only those that pass the metric in the compiled prompt. So that means the metric, so the metrics that you set is what's going to filter out uh, the gold uh, the gold standard, and that's what's actually going to dictate uh, what's the word I'm looking for, the benefit of your compiled program. Okay, so advanced it supports using a teacher program that is a different DSPy program that has compatible such structure for harder tasks. So uh, so I believe this is using DSPy few shot uh, to do fine tuning on a different DSPy program. Uh, yeah. So straight out the box, Bootstrap few shot is defaulted to your program, and it generates demonstration based upon your programs or what you have described in your modules um, uh, forward pass. Um, and so and what you have labeled in your train set. Uh, but as you see, we have a few different optimizers that we have at our disposal. We also have the most simplistic, which is labeled few shot, which is where you create your own dummy data set. Um, and then we have also the random search. So random search is different than few shot because random search it applies the bootstrap few shot several times within a random search over generated demonstrations and selects the best program over the optimization. So what that means is it'll find the best parameters for your few shot for your bootstrap program. Whereas few shot you kind of dictate it based upon the examples. This one kind of runs. It doesn't necessarily need examples. So the parameters mirror those for Bootstrap Few Shot with the addition of number of candidate programs, which specifies the number of random programs evaluated over the optimization, including candidates from the uncompiled program. Label Few Shot optimized program, Bootstrap Few Shot compiled program with unshuffled examples, and num candidate programs of Bootstrap Few Shot compiled programs with randomized example sets. Okay, so it can be used on all of the other ones as well. And then we have the Bootstrap Few Shot with Optuna, uh, which applies it with Optuna optimization, uh, which is uh, it runs trials to maximize evaluation metrics and selecting best demonstrations. Um, so I believe this one um, doesn't have the um, additional examples generated by the teacher. So it will just go through uh, what you have and it'll try to pick the best one. And then we have the KNN few shot, which selects demonstrations through the nearest neighbor algorithm to pick the diverse set of examples from different clusters. vectorizes the examples, and then clusters them, uses cluster centers with Bootstrap Few-Shot for bootstrapping slash selection process. So this will be helpful. This will be useful when there's a lot of data over random spaces. Using KNN helps optimize the train set for Bootstrap Few-Shot. So this one is for like larger data sets.
Thank
Okay.
you very much for explaining
So
that. Yes?
definitely. Uh, they also have optimizers for your signatures as well. So uh, uh, okay, so let's go over it. So automatic instruction optimization. So these optimizers produce optimal instructions for the prompt. So this is for your signatures. And in the case for me, my pro also optimizes the set of few shot demonstrations. So CoPro generates and refines new instructions for each steps and optimizes with the coordinate accent, hill climbing using the metric function and the train set. Parameters include depth, which is a number of iterations of prompt improvement the optimizers run over. So this will basically refine your prompts over and over again using with a coordinate sent. So yeah, and then the My Pro, it generates instructions in few shots, examples in each step as well. But this instruction is data aware and demonstration aware. It uses Bayesian optimization to effectively search over the space of generation instructions slash demonstrations across your modules. So MePro can be used for instruction tuning and also for like generating synthetic data and fine tuning that data, optimizing it. So optimize fine tuning. So this optimizer is used for fine tuning the underlying LLMs. So Bootstrap Fine Tune distills a prompt based DSPy program into weight updates for smaller LMs. For smaller LMs. The output is a DSPy program that has the same steps, but where each step is conducted by a fine tuned model instead of a prompted LM. So you're even able to do fine tuning on the underlying models. Okay, so Ensemble is where you actually take a set of programs and use either the full set or random samples of a subset into a single program. So you're able to basically take multiple programs and to use different parts of them into a single program. All right, so let's see. So yeah, and this kind of goes over like the use cases for each of the optimizers. It kind of gives you like a general rule of thumb. So it'll give you kind of like a guide. If you have little data, 10 examples for your task, use Bootstrap Few-Shot. If you have slightly more data, let's say 50 examples, use Bootstrap Few-Shot with random search. If you have more than 300 examples, you use Me Pro. And if you have been able to use one of these with the large language model, 7 billion parameters or above, and need a very efficient program compile, and you need a very efficient program, compile that down to a small language model with Bootstrap fine tune. So if you have access and you have the compute to be able to fine tune and you just grab a 7B model and go ahead and Llama 3 7B model and fine tune it down to your use case. And then you're able to use that in the composable app in a composable program however you need. So let's go over. Okay, so yeah, and you can also save and load your optimized outputs. So for example, right here we're gonna be set up the optimizer. We want to use Bootstrap for 8 examples, and we're gonna repeat this 10 times. and then we set our metric and we set our optimized program. So once we do that, we're actually able to save that program because it's optimized now, and we're able to use that later on downstream or in a different separate program in a separate program as well. Uh, the resulting file, so it's saving it the resulting file is a plain text JSON format. It contains all the parameters and steps in your source program. You can always read it and see what the optimizer generated. And then you can load it. To load a program from a file, you can instantiate the object from that class and then call the load method on it. So simple as that, right? Uh, so that goes over optimizers and using data sets and how you able to instantiate metrics with your optimizers, and then use them in different programs, whether it be RAG, multi-hop, RAG, or just simple data transformations with predict or chain of thought. Are there any more questions? Because this is just the simple DSPy or the simple basic DSPy. This isn't going over any of the advanced topics like assertions or type predictors.
That more than answers my question. You mentioned you had some examples that you'd like to demonstrate.
Yes.
I don't
So,
see any questions in the chat.
okay, no problem. So, yeah, some of the examples that I have ready are I have a few multi-agent demonstration or not demonstration notebooks uh, that the community have shared. I also have a couple single single agent demonstrations that I've created that I would like to also share. So let's start with chat with memory. Okay. So
Thank you. And
this
I'll
is a
interrupt and say you're still showing the documentation on the screen.
oh, apologies.
Oh, that's good.
All right. So
Thank you.
chat list with memory. So let's begin. This is a simple implementation of a chatbot using DSPy to instantiate a chat history. Um, it's only a rolling five uh, hit log chat history, but it gives you a simple look at how you can do simple things with DSPy and very small amount of code. So we have our chat list with memory module that we're instantiating. We so as you see here, we don't always need signatures or teleprompters or any of that. You can these are all operators that you can call however you need or like. You can just use the signatures if you would like, or you can just use the modules. It depends on however you would like to build your application. So here I'm just simply using uh, DSPy module. In there, I set out a memory array, and then I dictate the memory size. And then in there, I actually am using a signature, and I'm using it for the chat instance. I'm doing prediction on with the signature. I'm just instantiating a signature in a single line instead of using a class-based signature. So I'm doing message to history to answer, from the message history to answer. So it will always keep that in mind whenever it's doing a chat instance. And then through the forward pass, I'm going to append each message to the memory, and then going to pop off each one at the end, and then we're just gonna run that through the response based upon the combined context and the history, and then we're going to return a response based upon the chat instance always getting the combined context in its history. And then we simply instantiate a chatbot with a while loop with simple inputs with you, and then you give it some exit command, and then yeah. So and then we instantiate our module at the bottom with simple DSPy, OpenAI, and then settings configure, and then we instantiate our chat, and we start the chat session. All right, so let's run this.
Just a quick question while you're launching. I don't see this example agent in the DSPy code. Is this a personal one?
Yeah, so now I'm actually showing you all personal implementations. So
Yeah, got it. Thank you. Or
I,
maybe if you wanted to share that list, that
yeah, I can
file,
definitely,
that'd be pretty cool.
I can definitely share it. Oh, sorry, hold on, let me get to. All right, so now we have begun the conversation, and let's go ahead and say I am well. Today is Wednesday. How are you? Oh, hold on. Let me.
The dreaded secrets.
Yeah. One moment. Let me.
Yeah, definitely don't click on that file.
Let me stop there for a second. All right. Let me fix this. Uh, I'll just have to change that later. That's okay. Uh, hmm. Okay. It says the OpenAI key variable. Um. Oh, let me do that then. It,
Should I start my OBS so I can capture that key?
oh man. Let's see. Oh, I gotta do it like that. Okay, hold on. So let's do this. Chat. Or okay. Read me correct. Okay, there we go. Um, okay, now we're back in action. All right, let's share the screen again. Let's delete this. Thank you. Control cancel. Control. There we go. That works. All right, let's go live. Alrighty, so
Thank you. We're good to go.
yep. And right. So hi there. How can I assist you? Uh, Today is Tuesday or Wednesday. It's a beautiful sunny day outside. Uh, how are you? Okay, so uh, let's see. Today is Wednesday, right? Good. What did I say to you first? Today is Wednesday. It's a beautiful sunny day outside. So, as you see here, it's keeping the memory. It was able to regurgitate what I said to it initially. I said, today is Wednesday. It's a beautiful sunny day outside. This was the first thing that I said to it. And then I just asked it, what did I say to you first? It said, today is Wednesday. It's a beautiful sunny day outside. So this is not that file. This is the
Before
chat
you
list.
pick
So
the
yeah,
next example, I have a request from the chat. Do you have any examples with optimization on code generation like Python code or SQL queries? That's a question from Akil.
so I do. I was having, or so this is my attempt at doing optimization, or I think you said optimization using Python code or SQL code. So as far as the optimization part, I'm not actually doing the optimization here, but I am actually doing web browsing and also code generation using the language models, using chain of thought and other predict modules. But as far as actual optimizing, I have not been able to get into that aspect. Let me think. Yeah, as far as using DSPy for optimizing code generation, um, I have some thoughts how that would look and what optimizers or yeah, what metrics would be used. But as far as actual implementation, let's see. Yeah, multi-document. I didn't bring that one in here. Yeah, I don't have one currently, and I don't believe that they actually have any examples available on the website either.
Thank you. There's a follow-up
Yeah.
question from Akil where he says that any tips might help. Um, and of course, optimizing code is kind of a broad subject. Are you optimizing for a particular usability quality? Are you optimizing for speed? Are you minimizing memory? Are you minimizing network traffic? You need to have pretty good instrumentation of the quality that you are optimizing for. Um,
Very true. I believe he's talking about uh, debugging, and debugging and what's the other one? Like unit tests, things like that. Uh, um, there was a so just to share, this is separate to DSPy. There was a announcement today, or not an announcement, but I would say a let's see, where is it? Insights. So there was a new agent that came out, I believe today, that was able to generate unit tests on their own. There was a whole repo related to it. I would have to do some searching to find it. I
is the
believe we were
one
just
you're talking about the Codium new tool that came out?
yes,
Okay,
yes,
I
that's
will.
exactly what I'm talking
I'll
about.
put it in the Research General channel. I have a link to the repository.
Okay, good. Yeah. So yeah, that I would say that is uh the vein that he is referring to. Like I've seen a lot of different like Llama Index, Codium, who else? There's another one. Um, but I have not seen a DSPy implementation of that. So from my dabblings with DSPy, um, you won't necessarily see that yet, and if you do see that, it won't be like shown to anybody, uh, because those are more productionized pipelines, fully productionized pipelines for like fully mid-sized businesses would take you know complete control, or they would it would be very valuable, that those pipelines. uh Sorry if I got confusing there, but I think that answers the question a little bit.
Yes, I think that's a great answer. And I'll also mention if you're using something like Postgres for your database, it includes a built in optimizer for SQL queries. So you can use Postgres to give you optimized queries without having to use any of these tools at all. That's built in to Postgres.
Nice, nice. So yeah, uh if you're running some type of service using Postgres, that's something, or not Postgres, SQL databases, that's something that is a really useful tool. So this is another novel pipeline that I created early in the beginning. I would say probably around January. But yeah, this simply uh, is a news summarizer, and what it will do is it will scrape uh, Wikipedia for an article based upon um, the design. What is it? Hold on. Where am I? Oh, the article URL. So I'm gonna summarize the DSPy minimal example, and it will do optimization through this teleprompter which I'm not actually giving it any parameters. I'm just running it through it. Uh, and but with the actual web scraping, we're just doing simple using requests, um, scraping the website, grabbing the article, and then we're gonna use the signature, which is gonna be article, and then well, the signature is summarization signature, and in that we're gonna have article and summary. The article is gonna be the input, the summary is the output, and then we just define our program, initialize everything, have the DSPy predict module with the summarization signature, and then run it through our forward pass, which is article, which is going to be the article, um, and then we're going to summarize it through the summarizer, or through the summarize, which is going to use the article, and then it's going to return the summary, and it's going to do all that through the predict module. Uh, and then I just initialize a teller prompt just because, and then this is where you instantiate everything. Article text, which is going to be the scraped article content based off the URL. And then we're setting the example objects here. And then we're going to actually compile it in order to get a better summary. And then we're going to generate a summary based upon the scraped article here. So I tried to run this earlier, and so I'm running this using Anthropic. So I've actually, so they have it in there. They just haven't updated a crucial init file. But yeah, so they have Anthropic. You can use Anthropic models as well. So let's run that.
That's prompt. I'm sorry. It's a little slow.
What'd you say?
It's a little slow.
Stuck on 0.
Well, yeah. I believe that it's scraping the data, or not scraping the data, but it's running the entire article through the teleprompter, which takes a little bit of time. It takes 41 seconds. But after it ran it through, it should be able to generate the actual summary based upon the Anthropic API, if it's stable or not. Um, okay, so it was able to do it. So let's make this a little larger. So Bootstrap, one of them, and it gets printed out the article URL, which is this, and then it gives you the generated summary article. Quick start. This is a quick start summary, quick start minimal working example on this page, and then it gives you, we walk through similar, it gives you, it basically is explaining this example to you, right? And then it gives you a summary. This article provides a step-by-step guide on using the DSPy. So this was the article, right? So this is the article. This is the actual article. And then it's going to give you a summary based on that article. This is the article provides a step-by-step guide on use DSPy library to create a minimal working example. It demonstrates how to, gives you all the steps, right? This article encourages reader to adapt and expand this example to suit their specific use cases while exploring the capabilities of the DSPy library. So that basically, so this summary is this entire article. This whole article has been condensed down to this summary using this compiler. So it just compiled it, and it was able to uh, compile that entire summary down. So now it should be able to. So if we save this, we should be able to load this and run this without actually having to run through all these examples. You see now, so like once you run it through the examples and then you compile it and save it, you can load it back without having to run through all those examples again to get that optimized program. So now I've created a news program that I can save and use in other programs, or I can extend this and use it downstream again without having to run through the compo the comp the bootstrapping.
The optimization. So no longer need to optimize. You could switch in the article URL to a different article and it would run local without running to Anthropic, is my question.
So no, it still will run through Anthropic, but it has the most optimized settings or prompts in order to get the most optimized summary. Uh, so
I
when it
see.
went, so yeah, when it went through these examples or whatever, what took so long was it was running through a bunch of different examples to get the most optimized prompt in order to get the desired results, which what I want is a summary. So it got the most optimized
Okay.
prompt to generate the most optimized summary, and then it gave me that optimized summary based upon that optimized
And
prompt.
gotcha. That cleared it up for me.
Mhm.
Are you able to then share with us the optimized prompt that it generated on that previous run? So I
Yeah,
don't really care about the summary. I now care about the optimized prompt. So I'd
yes.
love to see the output of that run.
All right, let me.
You guys gonna do me a favor, all of the photographs, pick them up, put them on my table. It's not difficult, just do it for me, please. Pick up the photos. Put them on your bed.
So okay, so it's gonna run through it again because I don't have it where I'm saving. Uh, grab that. I think it was at the bottom. Oh no, that wasn't here. It was actually in the website. So
So the claw.inspect history is the generated prompts.
yes, so it will show you exactly the LM call that the Anthropic API received.
Got it. Okay. Which is equivalent to the optimized prompt.
Exactly.
Got it.
Go to here. Let's do this. right. So as you see here, so with hold on. Let me make this bigger. Okay. So it's showing let's see. Okay. So we get right here. Yeah, this is the summary. And then summary ends right here. Okay. This is what the LM sees. So the LMC is given the fields article, produce the fields summary. So this is our signature, and then this is our forward pass. So follow the following format: article, and it's going to spit out the article, and then summary. So it's going to give you the article, and then summary. Right. So article, quick start minimal example, right? And then the summary is going to be the article as well, right? But what we're going to do is we're going to tell it to refine on that, and then that's where it actually comes out with the summary here. This is the refined summary. So this article provides a step-by-step guide on using, because we're returning the summary. This is the so this is what it returns at the end. This article provides, and it shows you, you know, the exact output that we got at the very bottom. And then, yeah, we're also able to save this as well as a plain text JSON file, and then load it as well in another program if need be later downstream, or in a separate application. So let me move on this. Okay. All right, so that's news, and then there was another one I wanted to show off, which is Storm. Okay. Hold on. Okay, so let me just do this. Oh, maybe I shouldn't have done that because I had the but I'll do it again. So CD slash. So earlier in this year, Stanford, some Stanford graduates, they or professors from Stanford, they researchers from Stanford, they released Storm, and I using DSPy and also ChatGPT and couple custom GPTs I created. Using their research paper, I was able to recreate a semblance of their pipeline, and this is that. Oh, yep, gotta hold on. All right. Wrong one. Excuse me. All right, let me grab my key 1 second.
Batman, I have to go. I just want to say thank you, but I have another appointment. Thank you so much. Appreciate it.
Oh yeah, no problem. And be sure to DM you the links and everything.
Yeah, thank you so much. Appreciate that again too.
You take it easy. It's all right. Should we see if it works in my command console? So, so we'll just run it. All right. And then okay. It's- Interesting.
I'll remind you to revoke that key after this is done.
Oh, I see now. I'm sorry. I'm sorry.
Oh, you're good.
I forgot. I do that right now then, because that was simpler than I thought. Okay. Try that.
So while you're revoking it, can you tell us what Storm is supposed to do?
So yes, Storm is my attempt at creating a article generator based upon the Wikipedia dataset. So given a query or a topic, it will scrape the Wikipedia dataset, Wikipedia website. It will run through table of contents. It'll also run through certain topics, and then it will actually generate a question and answering conversation between two agents that will further explore the different topics related to the query, and then iterate upon all of that, and then combine all of those outputs in a multi-hop fashion to come up with a generated article.
Well, that sounds really useful.
Yep, and there we go. So let's take a look at what we got. All right, so as you see here, we've gotten, okay. So first, I guess we should look through the code. Yeah. So I am using Pydantic models. And also I'm using I have a utils folder which I instantiate a fetch Wikipedia links method, and also a fetch table of contents method. And what the utils does, we can go look at it, is it uses the Wikipedia API that doesn't need a token, so it's able to actually efficiently search and pull from the Wikipedia website. Okay. And then, so I create some base models in order to dictate the structure of the link data and also of the table of contents, so we can have structured outputs or coherent or consistent outputs each time. And then also we instantiate a conversation signature, which has a topic, perspective, conversation history. It also has question and answer. And with all of these, I'm giving descriptions too. So this is going to be main topic, perspective for the conversation, previous conversation history, optionals true, generated question, synthesized answer. That's with the conversation signature. Then we have the research signature, which has a topic, related topics, table of contents, which has two outputs, which will be the related topics and the table of contents. And the input is the topic. Okay. And then we have the generate table of content signature, which has, well, it's all pretty self-explanatory. Okay, so then we have our first module, right? We have our full article creation module, which it will be using chain of thought with the combined signature. So what the combined signature does is it pulls different inputs from each of the separate signatures. So it has a topic, content, prompt, and full article, and then we're dictating each of these. So this is gonna dictate the format in which the process article is going to take place in the chain of using the chain of thought pattern. And in that, we're going to first generate the full article based upon the conversation history and the prompt. So we're going to create we're going to leave an array open to join the content, which will be the answer for each question that's had in the conversation history. And then we're going to add that to the full article. Oh, and then we also are able to so I actually incorporated this. This was one of the latest incorporations. So there's actually a roadmap for this. This isn't done. And I haven't used any of the code that Stanford came out with. I only used their paper. But I have it where you can dictate each of the article's target token length. So this one's going to be 800, and then I set each of the paragraph length to 65. And I found this is the sweet spot to get a really nice, robust article. You can make it smaller, which still works, but not for complex things that I'm trying to do, or complex topics that I was trying to incorporate. But anyway, so this kind of breaks down the full creation of the article with the prediction module. So it will actually be creating it each. So it'll create each line by segment, and then we go down to the research and conversation module. So what this will do is it will be doing chain of thought with the research signature, and also it'll also be using the generate table of content signature, and also the conversation signature and the perspective signature together with the full article creation module. And it's going to take the topics, and then it's going to turn that into a data, which will be used in the generate table contents module, which will be formatting it with the link data. And then we're going to set the rationale, because you can actually set the rationale as well. Just like with signatures, you can set the inputs and outputs, but you can also set the chain of thought rationale. You can dictate it. And I'm saying to generate a detailed table of contents. And then, so we're also going to say if it doesn't as well. And then we got the perspective outputs, which is going to be based upon the topic, and then conversation history, have that formatted, and is based upon the initial query, and then formatting it all, conversation output, and then we're going to update that history each time we have a conversational output, which is the question and answer. Now, the prompt that I have is the impact of sustainable energy on global economies, and it will use that prompt in order to generate a question answer article based upon that. Okay, and to do research and everything as well on that. So the research and the related topics. So it's gonna return the research, which is gonna be the related topics, the table contents, and then conversation, which will be the next question. So this is the format it's gonna show, and then the perspectives, and then the last the generated article. And then this is everything together, and then printing the integrated research. So this is actually printing each module. Each modules for the perspective and the article outputs. And then, so if you see here, we have so I like I said, I have to do some updates because right now it's where so I can actually have, and I found that it kind of messes the quality of the article up. But if you have an unrelated prompt here and your topic isn't related, it will create an article, but the article will be kind of convoluted. Whereas this one is a really good article. Um, I think I had no, I didn't. I didn't. But I had plans to do some optimization, and like put some relevancy metrics in there, and some readability metrics in there, in order to optimize this article even more. But without optimization, it's been able to generate a really decent article. So we have uh, integrated. Hold on. So this is just showing you the modules that it's going to be pulling from. So, and then the JSON format of it. So we have the table of contents. Sustainable energy is the topic, and then it's giving you the related topics to that, and then the reasoning behind it because you're doing chain of thought. Uh, so this is that output, and then it has a conversation, which we're going to have a conversation with um, a module with the conversation research and conversation module, which is going to ask what is the sustainable energy, and it's going to go through each of these questions and give us an answer. Sustainable energy refers to the development and use of etc. Right, and then it's going to go through each of those questions, right, and then it's going to add those to the history. Okay, and then it's going to add all of that together and then generate perspectives. Okay, and then those perspectives, as well as the question and answers, will be combined in order to generate a article.
So thank you so much for doing this, Batman. This is a much more detailed example than these tools usually get. And I have to say that this gives me just a much more thorough understanding of what DSPy can do and has given me many good ideas on projects that I might want to work at. I would like to thank you so
Definitely.
much for doing this. And if you ever have anything else you would like to present on, we'd be happy to host you.
Thank you, thank you, thank you. All right, well then, yes, this will wrap up my introduction and workshop into DSPy, and I hope I was able to enlighten everybody.
Thank you so much.
Thank you.